Hi. So, the purpose of this lab is to observe and to model the interaction between a falling magnet and the tube of aluminum foil. The magnet acts as an external source of magnetic field and induces a current inside the foil. The main objectives are to obtain observational data, to model the interaction computationally, and to compare the observed data to the computational predictions. The physics principle used, the Biot-Savart law, Faraday's law, Lenz's law, Newton's second and third law. Lab procedure: 1. To find the north pole of the magnet. 2. Drop the magnet through the tube. 3. Calculate or record the time it took for the magnet to fall through. 4. Finally, repeat this procedure 5 times. Here's my measurements in the table that shows all 5 drills, which has an average time of 0.788 second. And here's all the measurements I have for the tube and the magnet. Here's my code. I first initialize all the constants in the graph, creating a tube of the foil and the simulation of the magnet falling through. Then I split the tube into a series of rings, create the bar magnet, and initialize it to be at rest. These two parts are the functions that calculate magnetic field and changing flux through each ring. The while function creates falling magnet simulation, and this whole part calculates the magnitude of each force acting on the magnet. The final part updates the velocity and position of the graph. And here's the result I got, which is the computational time for the magnet to fall through the tube is 0.728 seconds, and that is pretty close to my experimental data, which has an average time of 0.788 seconds. And I will show the result. Okay. The Q&A part. So if the resistivity of the conductor will reduce, the magnet will be falling slower and the induced current will be larger than the gravitational force. And if the holes or slots were cut into the tube, that will reduce the number of rings and the magnet will fall faster in this case. Thank you for watching.